Good afternoon to 100% over here. So today our topic is about linear variable differential transformer. Okay, that is in short form what we'll say about an LVDT. Okay, the LVDT, that is a linear variable differential transformer, is a passive inductive transducer finding many applications. Okay, the most widely used inductive transducer to translate the linear motion into electrical signals is the LVDT. Okay, so when you're saying about principles of LVDT, actually the LVDT works under the principles of mutual induction, and the displacement, which is a non-electrical energy, is converted into an electrical energy. And the way how the energy is getting converted is described in working of LVDT in a detailed manner. Okay, and apart from that, the passive inductive transducer to translate the linear motion into electrical signals. Okay, so this is about the construction of LVDT. Okay, so when you are saying about that basic construction, actually the transformer consists of single primary winding P, and we'll have often two secondary windings S1 and S2. Okay, which is to be wound on a cylindrical former. Okay, and apart from that, a sinusoidal voltage of amplitude 3 to 15 volt and a frequency 50 to 20,000 hertz, which is used to excite the primary. And the two secondaries, which will have a equal number of turns, and they are identically placed on either side of the primary winding. Okay, so we'll have often single primary winding and two secondary winding, which will be wound on a cylindrical former, and we'll have the amplitude of around 3 to 15 volts and the frequency 50 to 20,000 hertz over on it. Okay, and the two secondary will have a equal number of turns, and which will be identically placed on either side of the primary winding. Okay, so where the primary winding is connected to an alternating current source, AC source, we'll have often a mobile soft iron core which is placed inside the former. Okay, and the displacement which is to be measured is applied to the arm attached to the soft iron core. Okay, and when you're saying about an in practice, the core is made up of an high permeability nickel ion. Okay, and this is slotted longitudinally to reduce the eddy current losses. Okay, and when we are saying about it, all the assembly has to be placed in a stainless steel housing in order to provide electrostatic and electromagnetic shielding. Okay, and the frequency of AC signal which is applied to primary winding may be between from 50 to 20 kilohertz. Okay, and when we are saying about a primary winding which is excited by an alternating current source, so what will happen now? It will produce an alternative magnetic field, and then which in turn induces alternating voltages in the two secondary windings. Okay, so the output voltage of S1 will be ES1, and that of secondary S2 will be ES2. Okay, so in order to convert the outputs from S1 and S2 into a single voltage series, so the two secondaries which are connected in series, so that will be shown over here. So that the differential output voltage, that is E0, is equivalent to ES1 minus ES2. Okay, so we'll have often primary coil and two secondary coils. So we'll have a differential voltage V0 is equivalent to V1 minus V2. So this LVDT will consist of a cylindrical former where it is surrounded by one primary winding in the center of the former and the two secondary windings at the sides. Okay, and what about the working of LVDT? So we have to apply an external force. Okay, so which is the displacement. If the core remains in null position,